Hello everyone. My name is Mukwaba Dennis, and I'm going to take you through MLOPs for explainable graph neural networks for employee attrition. Um, well, this is what we have: data processing, model development, MLOps tools, model deployment, monitoring, challenges, solutions, and impacts on the project. So we'll go straight to data processing, where we had to define target and independent features. We removed features from with zero variance, then separated feature into numeric and categorical. Sorry. Then we had to remove outliers through outlier analysis of numerical features. Then we selected features, that is categorical features and numerical features. Then we worked on imbalanced data sets to balanced data sets. Then split the data set for training and testing. Then data transformation. We did data transformation using standardization. So in our model development, we had a number of models, but we went ahead to go on with FNN model, which is a feed-forward neural networks, because it is non-linearity, because of its non-linearity ability, sorry, which is the ability to capture complex non-linear relationships between input features and the target variables, which we have a simple snippet here of our code. Then the tools we used, we had the ML Flow, we had the DVC, we had the Dev Container, then Grafana and Prometheus. Taking you through ML Flow here, ML Flow is used to version the trained models as each run is logged, and the model is saved together with relative model evaluation results. Yeah. Then we had our DVC, which is basically for versioning our model. We use it to version trained models and store our CSV data. Then we had our dev container. Basically, we use the GitHub's dev container for containerization. Then we utilized, basically that's it. Then for Grafana and Prometheus, we used it to monitor our deployed models, looking at uptime, which is the total time the server has been online, offline, then reachability, average latency, then frequency. And then we looked at how we deployed our models. We used the render, as you see here. We used a couple of deployment tools, but they were all failing, but we eventually got one, which is here on render. Then we had challenges, of course, where our first challenge was in regards to development, where we had no comprehensive knowledge of the development models, which model to use exactly for in regards to our project. Then the other is model deployment. We lacked accurate knowledge on the free hosting sites or platforms to use for our model. Then it was so time consuming, as we can all see. Then its impact, basically the model deployment has greatly added value to our model, as it can now be accessed by anyone and be used to make prediction about employee attrition through the API. So in conclusion, if you have any questions, please leave them in the comment section. Thank you. Good.
So I'm gonna go Claire. I'm gonna go Claire, and I'll be taking us through our code. And this is our preprocessor code. We defined this is the preprocessor, and we defined our target and independent features. And our target feature is attrition, and the rest are independent. Then on our next line, we remove features with 0 variance. Then we handle the cases where no features have more than one unique value. We set an empty index if no feature to keep. Then on our next line, we separate features into numerical and categorical. Then we remove our outliers, the outliers in our data. Then we scale our numerical features. And here we select K-based categorical feature. Then after we join all features. And because we actually used oversample instead of undersample. Then here we split our data into train and test. Then we defined our torch. Actually, that's what we used. Then from there, we go to our model code. And here we define our model, which is FNN. Then we shall cut also. This is our model code. Here we define our model, which is FNN with 3 linear layers, and we also define our forward pass function. And from there we go to our training file, contains our training data, and in this file we train our model. Then we convert xtrain to a compatible data type. Then we encode target labels. From there we reshape the Y-train, encoded to a 2D array. Remember, our data is in we are trying to in an object, we are trying to turn it into a graph. Then here we start our ML flow run. Then we log our hyperparameters. After logging our hyperparameters, we log training loss with ML flow. Then we save our model, still using the ML flow. This is our code for saving the model. Then from there, we evaluate the model. And here, on evaluation, we are looking for accuracy and the classification report. Still, we log the metrics using the ML flow.
Action.
My name is Makanga Christopher. I'm going to be continuing from where my colleagues stopped. So after defining our training function, our pre-processing, training, evaluating, and model, we come to the main Python file. And in the main Python file, what we are doing is we are instantiating an object of the other classes. Now, as we are instantiating the object of the other classes, first we load our, of course, we import the packages. Then we load our data set, which is HR employee attrition. It is part of here. And then we pre-process our data by creating an object of a pre-processing class, as the previous speaker talked about it, where we perform all these that she talked about. We define the features, we clean our data and everything, create graphs and everything. Then we build our model by passing there our pre-processed data. After building our model, we train our model on both data sets, on the training data sets, and then we evaluate our model on the test data sets. But thereafter, after training, we save our model. Now, this main.py file, once it is run, I've already run it somewhere. Okay, let me run it once again. Okay, as it runs, I'll be explaining the next file, which is app.py file. Now, app.py file is the entry point for our application. In our app.py file, we used Flask to create an API endpoints. And in our app.py file, first we import the packages. As you've seen, we create our app in Flask, and then we load our trained model. Let me see. Okay, so we load our trained model. After loading the trained model, we load it from MLflow. As you can see, this is the route to the MLflow. Then we can define a function to pre-process our data based on our pre-processing class. And then after defining a function to pre-process our data, we can then define the model. We can load the model, and then the trained model that we trained already, and we've loaded from MLflow, which stores our models. Then we can define our route. When we define our route, the post method. What happens when you post data to the server? Now, we could have used dynamic data where someone posts data to the server, but then since we did not create a dashboard really for someone to post the data, we put static data. So as you can see, that's an example of our features. And then we pre-process the data that we have put. After pre-processing it, we convert it to tensors, and then we make predictions on that data. After making predictions on that data, those predictions are returned to us in a JSON file data type. And then from there, we use the try and except block. If in case any error happens within, we can return it with the exception handler. And then we define the home route, as you can see. And then we defined, we requested our app to run on port 5001, and we set debug to be true, because we are still in test mode. Now, this is what happens when you load, when you run app.py. That's basically what happens. I don't know why GitHub Spaces is misbehaving right now. The terminal is not showing, but this is basically what happens when you run. And now the next thing that we shall be looking at is deploying our model. So we used render to deploy our model, and we deployed it on render. Let me see. We tried to deploy a number of models, but this was our first and only successful model for now. And we deployed it to Oregon in the US. We deployed from GitHub, and then that's the main.py. This is our build command, and we used Gunicon as our start command. Why did we use Gunicon? Because there would be conflicts among packages on the deployment server, and the Python file that we used in our development server. And then we got an API that we can use to post and fetch from our server. And then we we went ahead to use Grafana. Grafana is still opening, but we went ahead to use Grafana to monitor our model. As you can see, we are hosting it on these servers, and then our uptime is 100, reachability 100%, average latency 23.997 milliseconds, and frequency is 1 minute. And then what I had not yet shown was our MLflow dashboard. Our MLflow dashboard, these are some of the models that we have posted, and yeah, these are some of the models we've posted together with evaluation data. And the last thing I would want to show, I would want to look at is let me see, just a minute. Last thing. Yes, I would want to show our code in GitHub. Yes. So our code in GitHub, this is how our code is stored in GitHub. And we have workflows. Yeah, we have these workflows which did not perform very well. But yeah, and we had to fix that. We fixed that already. And then yeah, the rest of the files, as my friends have talked about them. Thank you very much. Bye-bye.